So, this week, our first topic is equations. So last week we talked about algebra, and I went very quickly over a lot of stuff that you should be able to do. Hopefully I was just reminding you of the things that you had probably forgotten, but hopefully now have back in your armoury. And our first use of algebra is in working with equations, because an equation is just a statement of a form. One algebraic expression is equal to another algebraic expression. So that's what an equation is. And the notes try to differentiate between a formula and just an equation. It says a formula is true for all values of the variable. So it says here, A, the area of a circle is pi r squared. So that's always true. So that is a formula only in the sense that we are thinking of circles when we see that. All right? So if we're saying this is referring to circles, then that's always true. That equation represents a formula. Whereas for an equation like this, 3x squared times y minus 12 is equal to 0, for this statement to always equal, well, for the left-hand side to be the same as the right-hand side, that's only true for certain values of x and y. For example, in here, what could I put? E.g., I might put, for example, I could put y equal to 1, and then x would have to be equal to 2 in there. Then that statement is true. Okay? So that's what we mean by an equation. So we're going to have a look at how we might find these particular values using our algebraic techniques, algebraic manipulation that we're good at. But before we do, okay, one of the things that we might want to do is change the subject of a formula. So what we mean by that here is we want to write one pronumeral or one variable in terms of the other variables. That's what we mean by make the subject of. So for example, in this equation here, y is equal to x minus bx plus c. Y is the subject of that formula at the moment. This question says make x the subject. So I want to write x in terms of everything else in here. So at the moment, y is the subject. There, and I want to make x the subject. And what it says to do is you need to do the inverse of each operation sitting in here. So think to yourself, if I were to substitute the value for x in here and evaluate it, what do I have to do? Well, I'd substitute x in, then I'd multiply by b here. I have to do the multiplication first. And then I have a number, and then so lastly I would add, well, I'd subtract those, and then I would add c. All right, so I'd work out that value, subtract them, and then I would add c. So to make x the subject, what you do is completely do the reverse of that. So the last thing I did was add c. So the first thing I'm going to do is subtract c. I'm going to take the inverse operation of each term here in the formula. So let's do that. So perhaps I might write it like this. To make life easier, put all terms involving x on the left-hand side. That's my aim. That's the first thing I'm going to attempt to do. So in this case, it's fairly easy to start off doing that. I'm just going to swap the left-hand side and the right-hand side. So if y is equal to x minus bx plus c, then x minus bx plus c is equal to y. So I just swapped the sides there. Now I only want terms involving x on the left-hand side, so I'm going to subtract c from both sides. So that's my inverse operation here. If this number on the left is equal to the number on the right, if I subtract c from both of them, they're still going to be the same number. So I can say here, x minus bx plus c minus c is equal to y minus c. Of course, you don't have to write that step in. I'm just putting it there to show you what I'm doing. Now, so let me write it here. So then I have x minus bx is equal to y minus c. Now in here, if I was substituting the value for x, I'd put it in here, work out bx, and then work out x, substitute it in here, and then subtract those two values. I would have to substitute for x twice. And what I really want to do is only substitute for x once. So to make it so that I can do that, here I'm going to take x out as the common factor. I'm going to say, write the left-hand side as x lots of 1 minus b in there. So in here, I've factorised in there. And so now if I were working out things in here, I'd just substitute for x once and then I'd multiply by 1 minus b. So to undo that, I shall now divide by 1 minus b, and x times 1 minus b divided by 1 minus b is just x, and on the right-hand side I have y minus c over 1 minus b. And there it is with x as the subject. So the whole point is to keep performing these inverse operations until I get x by itself. Here A is the subject, and it says make R the subject. So in here, when I have R, I square it, then I multiply by pi. So to make R the subject, I'm going to do the inverse of those. I'm going to go back the other way. So I'm going to say pi R squared is equal to A. I've just rewritten the left-hand side and the right-hand side, just swap the sides. Now I'm trying to isolate the R, so I will divide by pi. So R squared will be A divided by pi. What's the inverse of squaring? It's taking the square root. So now I will take the square root of both sides. So in here I'll just say divide BS both sides by pi, and in this case I will take the square root of both sides in here, and the square root of R squared is R, and here I have the square root of A on pi. And in this case I'm only going to take the positive value because I'm thinking of this as a circle. So I'm going to say my radius is positive in there. And so there I have made R the subject of that formula. This next one's a little bit more complicated. It says make X the subject, and I have an algebraic fraction over here on the right-hand side. And that's a little bit awkward to work with. So my first task in this case is to get rid of the algebraic fraction because I can't do anything else with that. So what I'm going to do is I'm going to multiply both sides by the denominator here. So this will be I times x plus r is equal to yx on x plus r times x plus r. So that is just y times x. So I've multiplied both sides by the number x plus r in there. Now I want to get all the terms involving x on the left-hand side, but x is in this bracket here. So I have to eliminate, I have to expand out the grouping symbols if you like. So here I'll multiply this out and I'll have ix plus ir is equal to yx. Now I can put all the terms involving x on the left-hand side. Here's one term involving x and here's another. So I have ix minus yx, subtracting yx from both sides. And I don't want this term here, the ir, because it hasn't got an x in it. So I'm going to put it on the right-hand side. And I do that by subtracting I times r from both sides. So here I expanded the brackets. Here I subtracted yx from both sides, and I also subtracted IR from both sides. I did both of those things in there. I did 2 steps. Now I have x in both of these terms. I can factorise to make x isolated. So here I can have x times I minus y, and just check, I times x is ix, x times minus y is minus yx. So that's the correct factorisation, is equal to minus IR, and now all I have to do is divide by I minus y. And so that ends up with x is equal to minus IR all over I minus y. And there is x as the subject of that equation.